Welcome, data professionals. Today we are exploring Cortex Complete, officially updated to AI Complete. This is your primary function for generating text and holding conversations with powerful large language models directly inside Snowflake. Let's get started. Let's start with the basics. What exactly is Cortex Complete? It is a fully managed, general-purpose AI function built natively into Snowflake. You provide it with a prompt, and it generates a text response, or completion, using a state-of-the-art large language model. Note that while it was originally called Complete, Snowflake recommends using the newly updated version named AI Complete for the latest functionality. Why is this so revolutionary? Traditionally, generating AI insights meant extracting your sensitive data and sending it to external APIs, which creates huge security and governance risks. With AI Complete, the models are hosted within Snowflake's secure perimeter, meaning your data never moves. You just call the function in SQL, pass your model choice and prompt, and let Snowflake handle the complex infrastructure. Take a look at this high-level flowchart. On the left, we have your raw structured or unstructured data residing safely in Snowflake. Instead of building an external pipeline, you pass this data directly into the AI Complete SQL function. The function securely routes your prompt to a Snowflake-managed LLM in the center like a Llama 3 or Mistral model. The LLM processes the prompt and returns the generated text output directly back to your SQL result set. The entire process is contained, secure, and incredibly fast. A major advantage of AI Complete is model choice. You aren't locked into a single provider. You can select from a wide array of industry-leading models, such as Anthropic's Claude 3.5 Sonnet, Meta's Llama 3.170B, or Mistral Large 2. This flexibility allows you to right-size your architecture. For simple extraction tasks, you might use a fast, cost-effective small model like Llama 3.8B. For complex reasoning, you can easily swap the parameter to a massive, highly capable model. However, with great power comes the need for governance. To execute this function, a user must be assigned a role that has been granted the Snowflake.Cortex user database role. This ensures that your administrators use Snowflake's native role-based access control to strictly govern who is permitted to consume AI compute credits. This architecture diagram illustrates the access and routing flow. At the top, the user role attempts to execute a query. The gateway checks if they possess the required Snowflake.Cortex user database role. Once authorized, the request proceeds to the AI Complete function. From there, the developer decides the routing. Depending on the complexity and budget of the task, the function delegates the prompt to a small, medium, or large model family. This modularity gives architects total control over price-to-performance ratios. Now let's explore how to structure your inputs. The most fundamental concept to grasp is that AI Complete is entirely stateless. It does not remember your previous questions. If you want to build a conversational chatbot experience, you cannot just send the newest question. You must pass the entire conversation history into the function using an array of JSON objects. Within this array, every message must be tagged with a specific role. The system role is used at the very beginning to give the AI its persona and background instructions. The user role represents the prompts submitted by the human. Finally, the assistant role represents the past responses generated by the LLM. By feeding this chronologically ordered array back into the function, you give the LLM the context it needs to provide a seamless, stateful conversational experience. Let's trace a multi-turn conversation using this sequence diagram. In the first interaction, the app sends an array containing a system instruction and a user greeting. AI Complete processes this and returns an assistant response. In the second interaction, notice how the app must send a much larger payload. It resends the original system instruction, the first user prompt, the previous assistant response, and finally the new user question. This expanding payload is necessary because the Snowflake function is stateless. The app is responsible for holding the memory and passing it back on every turn. To move from a beginner to an expert, you must learn to control the model's behavior using hyperparameters. You do this by passing an optional configuration object to AI Complete. The most common parameter is temperature, which ranges from 0 to 1. If you want factual, deterministic answers, set it near 0. If you want creative brainstorming, push it closer to 1. A related setting is top P, which restricts the diversity of the vocabulary the model considers. You generally adjust either temperature or top P, but not both simultaneously. Finally, we have max tokens. This is a critical safeguard. It sets a strict limit on the length of the response, defaulting to 4096. Setting max tokens ensures that a hallucinating model doesn't generate endless paragraphs, which protects your compute budget and ensures predictable application behavior. This diagram visualizes how hyperparameters shape the final result. The input prompt enters the options gateway. If we configure a low temperature like 0.1, the path branches to an analytical and strict output. If we configure a high temperature like 0.9, it branches to a creative and diverse output. Furthermore, if we apply a max tokens limit of 100, the path ensures the output is short, truncated, and cheap to execute. All these modifiers act as filters before delivering the final output to the user. Here is where AI Complete truly shines for data engineers: structured outputs. Historically, building pipelines with LLMs was fragile. You would ask an LLM for JSON, but it might add conversational filler like, "Here is your data," completely breaking your downstream parsing scripts. AI Complete solves this natively. By using the response format option, you can supply an exact JSON schema. The engine then forces the model to adhere strictly to that structure, verifying every single token it generates against your rules. This eliminates the need for messy post-processing. As a best practice, always utilize the required array in your JSON schema. This instructs the model that it must extract specific fields, or it will intentionally throw an error, preventing incomplete data from quietly slipping into your production tables. Look at the mechanics of structured outputs here. We feed two things into AI Complete: the raw prompt containing our data, and a strict JSON schema defining our desired structure. Inside the Snowflake engine, a token-by-token validation process takes over at the enforcement engine node. The model is physically constrained from outputting anything that violates the schema. The result, on the far right, is a 100% valid JSON object that can be immediately queried and flattened using standard Snowflake semi-structured data functions. When deploying AI into production, safety and brand protection are paramount. That is why Snowflake integrated Cortex Guard directly into the AI Complete function. Cortex Guard acts as an automated safety referee. To enable it, you simply set the guardrails parameter to true within your options object. Before the generated response is sent back to your application, it is intercepted and evaluated by a specialized safety model, currently Llama Guard 3. If the output contains violations related to hate speech, violent crimes, or self-harm, it is automatically filtered out. This gives you peace of mind when building customer-facing chatbots. Do note that because this requires running a secondary evaluation model, enabling Cortex Guard incurs a small additional compute cost based on the tokens it processes. This sequence diagram shows the invisible safety net provided by Cortex Guard. The query asks the LLM to generate text. Instead of returning it immediately, the LLM passes the draft response to Cortex Guard. Cortex Guard evaluates the text against safety policies. If the is safe condition is met, the response flows back to the user. If the is unsafe condition is triggered, the toxic payload is dropped and a blocked output message is returned instead. Your application remains secure. Let's apply this to a real-world scenario. Imagine you work for a major retailer with a table containing millions of unstructured customer reviews. You need to extract actionable metrics, but reading them manually is impossible. We can solve this with AI Complete. You write a standard SQL select statement, passing the review content column directly into the AI Complete function. Using string concatenation, you provide a prompt like, "Analyze this review and extract the overall sentiment, the main product mentioned, and a one-sentence summary." By leveraging the structured output option we discussed earlier, the LLM processes every single row and returns a perfectly formatted JSON object. In minutes, you have transformed a massive unstructured dataset into a structured table that your BI team can immediately connect to their dashboards. Follow the data flow in our real-world use case. Starting at the raw reviews table on the left, the data streams into our SQL query executing AI Complete. The LLM engine simultaneously performs two complex tasks, extracting entities like product names and determining sentiment like positive or negative. The output converges into a new structured JSON table. From there, the data flows effortlessly into standard BI dashboards, giving executives real-time, AI-driven insights into customer satisfaction. Finally, let's discuss best practices and cost management. AI Complete is built based on token consumption. You pay for both the input tokens you send and the output tokens the model generates. Therefore, keeping prompts concise saves money. When running this function across millions of rows, One bad record could fail your entire query. To prevent this, use the try complete function. It works identically, but if the LLM encounters an error, it gracefully returns a null value instead of crashing your pipeline. Also, always test your prompts on smaller, cheaper models like Mistral 7B first. If they achieve high accuracy, use them in production to maximize your ROI. Thank you for joining me today. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final diagram summarizes the economics and best practices of Cortex AI. Both your input tokens and your output tokens aggregate into your total tokens billed. To optimize this consumption, you must route your strategy through our best practices node. This means utilizing try-complete for robust error handling, selecting the smallest capable model to minimize the per-token price, and leveraging structured outputs to ensure you never pay for useless conversational filler. Implement these, and your AI pipelines will be highly efficient.